All right, let's look at part E here, right? Sketch on the graph the variation of time with the displacement of the point the ball's dropped close to the Earth. For this sketch, take the direction toward the Earth as being negative because there's not a lot of room going up, right? Okay. What you want to do is here's what I did. Okay. I used, of course, the displacement's going to be VIT. Whoops, what am I doing? S is UT plus 1/2 AT squared, right? The initial velocity is 0, right? So the displacement will be 1/2 AT squared, right? And your acceleration will be negative 9.81. And then T is whatever you plug in. So just basically make a graph. Here's what I bothered to do, was I figured out what it was at 0.5. So I plugged in 0.5. And I got that displacement, which was like, I don't know, negative 1.2 or something like that. And then I figured out where it hit the bottom of this thing, right? Okay, so I actually plugged in here and figured out the T that it hit that at. And I think I calculate that. I can't remember what I got, but it's something like point, I don't know. I'm looking at this. 0.8, 0.7 or something like that, right? So I figured out where it intersected 3.5. I solved for this, right? Negative 3.5 equals 1/2 negative 9.81 T squared. I solved for T, right? And that'll tell you where it exits the bottom here, okay, on the time scale. And then I actually solved for the displacement. It ends up being something like 1.2 or something like that. And then I just drew a nice curve through that point, through this point, right? That's what they're looking for. All right. Good luck.